This is TechSNAP, episode 349. Welcome to TechSNAP, Jupiter Broadcasting's weekly systems, network, and administration podcast. We recorded this episode on December 21st, 2017. It's brought to you by our three great sponsors, IX Systems, DigitalOcean, and Ting. I'll tell you more about them as this here show goes on. My name is Chris, and joining us every week is the presenter, the engineer, and the debugger, Mr. Payne, Mr. Wes Payne. Hello, Wes.
Hello, Chris.
Wes, this is our second TechSNAP together. We have some follow-up on the show format itself, but we'll save that for the feedback section.
Yeah, sounds good. There's just too much fun stuff to talk about.
Yeah, we got to start with a TechSNAP classic. Brian Krebs has done one of his famous investigative pieces where he goes behind the scenes on a market for stolen account credentials. And it's a seller's paradise, Wes.
It absolutely is. It wasn't always a seller's paradise, though. So that's sort of changed over the years. Not a long time ago, in internet time anyway, right? Things so changed so fast. Your typical cybercriminal looking to access something like, a password-protected login for a page, maybe you want someone's Airbnb account. Mm-hmm. You would go visit an underground forum and ping one of several miscreants who routinely leased access to their bot logs. So these bot logs, they were essentially criminals, people who would sell these bot logs. They ran large botnets powered by malware that could snarf any password stored in the victim's web browser or credentials submitted into a web-based login form. That all gets sucked up. These bots suck it up, send it up to some master server somewhere, and then those get written out in logs. And then these, bot log dealers can send these to interested parties for a few dollars in virtual currency. A ne'er-do-well could buy access to these logs, or else he and the bot master would agree in advance upon a price for any specific account credentials sought by the buyer. So you can kind of go wholesale or try to negotiate for specific credentials.
You could also see where there'd be a negotiation in there like, hey, if you can get me credentials to this, it would be worth this much money to me.
Right, exactly. But back then, a lot of the credentials that a bot master might have, they weren't used, right? So he didn't spend that time trying to get all of them out of the logs, or people just weren't that interested. So there was a plentiful commodity. It wasn't that popular. It wasn't that profitable. But that has all changed.
Oh, good.
Now there's dozens of sites in the underground now competing to purchase and resell credentials for a variety of online locations. It's never been easier for a botmaster to earn a handsome living based solely on the sale of stolen usernames and passwords. Isn't that great?
That is interesting. So it's like botmaster is sort of an out-of-date term because now it's really more about stealing stolen credentials.
Right, yeah. How you get them is an implementation detail.
And, I think about this every time we hear stories like the Equifax leak or any large database. DJI had this massive breach recently.
Right.
And I think about, wow, that is just adding value to these botmasters, to these marketplaces. It's adding more and more things that they can just collect and add to their database. And as you would expect, when there is a lot of product like this, they can kind of divvy it up into different categories, and they can start saying, well, this type of product is worth more money.
Right. Yeah, you can put them in different bins.
Yeah. Which seems to be sort of what happened at Carter's Paradise, which is a seller's paradise. It's an online marketplace, which Krebs has some screenshots in the article, and you can see where they actually track earnings, and there's a whole seller's dashboard. They show you your current Bitcoin balance, how many clients you have, the total U.S. cash, and if you were to convert it to cash, right, what you've earned. It's a pretty sophisticated, almost marketable dashboard for this kind of...
Yeah, not a bad-looking UI.
No, it's really kind of... So this Carter's Paradise and the Seller's Paradise,
I think there's two sides of the same coin.
Yeah, exactly.
Right?
One's for the buyers and one's for the seller. So you get to see the front end and the back end in this article. It's just, you see in here too, they say that just looking at the graph that in the first 7 months of 2017, the botmaster that they were investigating sold approximately 35,000 credential pairs via the marketplace, that Carter's Paradise, earning him more than $288,000. So it's, an average of $8.19 for each credential sold through the service.
Interesting. What's also interesting is that there's a middleman here too, the service we're talking about. So based on the prices advertised, we can see that the service on average pays its suppliers about half of what it charges to customers, the people who actually come and buy those credentials. The average price for a credential for more than 200 different e-commerce and banking sites sold through the service is about $15 in USD.
Yeah, you want Airbnb? $15.
Yeah, right. Yeah, exactly.
Now, the more expensive ones might be like AT&T Wireless. If you get AT&T Wireless credentials, and you can get a combined login, like a credential pair, to the victim's email box, well, then that's a $30 combo bundle.
Yeah, for some reason, accounts for fries.com, those are like in high demand, I guess. That's selling for about $190. So, yeah, be careful with that one.
Well, if you want a login to a military personnel-only credit union, like, say, NavyFederal.com, that's going to be $60 a piece.
Yikes.
Yeah, I like just the arbitrary prices they have here, because if you want an AT&T Wireless account with somebody's email, that's $30. But you want a credit union, I guess it makes sense. I guess that kind of makes sense. It just seems like if you got that AT&T Wireless one that gets you access to the email inbox and the wireless account is a great deal. Because once you have we have said this so many times before on the show, once you get in the inbox, you're going to be resetting people's passwords like crazy, because all those emails.
You're pretty much in at that point.
You're in. So that $30 AT&T Wireless combo is the one I'd go for.
But wait, there's more. Okay. The service doesn't just sell credentials. It also peddles entire identities.
Oh.
Indexed and priced according to the unwitting victim's FICO score.
Oh, priced to the FICO score.
Right? So an identity with a perfect credit score can demand as much as $150. And, of course, the service also offers the ability to pull full credit reports on virtually any American for just $35 per bureau.
Really?
Yep.
The lesson from that there is if you don't want your identity stolen, have a low credit score. If you got a credit score around the 800s, you're a larger target.
Yeah, so trash your identity yourself. No one will want it.
Exactly. There's a TechSNAP pro tip for you.
So a good point here that Krebs makes. Crooks pay for access to these stolen credential services because they know that a decent percentage of internet users recycle the same password at multiple sites.
Uh-huh.
Right? We've talked about this a lot on the show as well. And so, if you're not already using a password manager, if you're not already using things like two-factor authentication for sites that support it, go do that today.
I like getting the real numbers on that stuff. It puts it in perspective, and it makes you realize, your stuff isn't worth as much as you think it is in that context. Well, I got a story for you, Wes. This is starting to get some momentum right here towards the end of the year, and it's FireEye making a big splash. They're reporting that a plant of an unmentioned nature and location, however believed to be in the Middle East, was forced to shut down after attackers targeted its industrial safety system. We've heard a lot of speculation about this kind of attack. It could be possible, this could happen, but this is the first known instance of a breach like this. It's going after the safety systems, and that's the key. And what it will do is it goes after workstations using the Schneider Electronics Trek Onyx safety system, which is typically used in, say, like power plants.
Oh.
The culprits hope to modify controllers that could pinpoint the safety problems, but some of those controllers then entered a failsafe state once they were compromised. Okay. And in response to that failsafe state, they shut down the plant, which people noticed, and that led operators to conduct an investigation that caught the hostile code. So if the attacker was a little more sophisticated, say more like Stuxnet, because this does start to make you think about Stuxnet. It
really does, yeah, industrial sabotage.
Yeah, then they may have been able to avoid this failsafe mode.
It does seem pretty lucky that happened and that we know about this at all.
According to FireEye, though, Triton was otherwise fairly sophisticated. It would try to recover failed controllers to avoid raising alerts if they did fail, and would even override its own program with junk data if it couldn't salvage a controller inside of a given time window.
Hey, yeah, that is pretty sophisticated.
Yeah. I mean, that really makes it a lot harder to do research. And FireEye says that the hack was consistent with a nation state.
It is worrying, too. I mean, power plants are crucial infrastructure, and especially in a region like the Middle East, you already have enough problems getting that stuff to work. You don't need these sorts of attacks.
Yeah, we have the source documentation in the show notes if you want to see FireEye's report. But I agree, Wes. It's like this is one of those situations where it didn't come through the internet. It came through a Windows workstation that was on the same network. And then from there, it spread quite a bit. And
Wow.
it's which they go into in some detail in the PDF that we have linked in the show notes. While FireEye speculates about the intent of the attacker, I'll just say it's good to see that these systems failed in a way that was safe, and obviously as they should.
Yeah, definitely.
But I think this is in some ways a success story because they failed correctly, they prevented a larger attack, And it was done so in a way that operators were notified immediately, and FireEye was brought in to do an analysis. Now, whenever you bring FireEye in, they always say nation-state actor, but perhaps they'll release more source information. If we knew where the plant was at, too, that'd probably give us more indications of who could be behind it.
It's a difficult problem as well because, more as computers become just in every part of society, suddenly people who, maybe you're an expert at running a power plant, but you may not be, an InfoSec expert, but suddenly those are very important to the day-to-day operations of just about everything.
Yeah, and so what's the lesson that we can all take away from something like this? As I had said, go by the FireEye recommendation, and it doesn't just apply to control valve mechanisms. It applies to anything when technically feasible. Segregate safety systems and control systems from processes and control systems on other networks. So engineering workstations that are capable of developing code for controllers shouldn't be connected to the same network that those controllers are connected to. There should be some physical separation there.
Yeah, right.
And there wasn't in this case.
Physical separation, change management around how things are changed and modified.
And you can use that same, for example, here in the Jupiter Broadcasting Network, we have these dots, these Echo dots, and we have a bunch of these vulnerable smart plugs, I'm sure, because they're running like Linux 2.2 or 2.4. And so our approach there has been we just physically isolate them off on a separate network. And so they don't touch our production LAN at all. And they're not even a super high security risk, but that's how I just approach those kinds of things. I could only imagine control systems or monitoring systems, which stay tuned because we're going to talk about network namespaces and segregating things out, and this might be part of that. So we're going to dig further into this and how you could actually implement this on your local box later on in the show. But back to the story. I've been watching this Triton story really build steam for the last few days. I have a feeling we're going to find out more about this, and we may even, if I was going to make a little 2018 prediction here on the show, I bet you, Wes, we may even see other places come out and say, we've discovered this malware too.
I bet you're right.
ixsystems.com/TechSNAP. Go there to learn more about IX Systems, a company that's driven by open source and builds the best solutions around it to power it. If it's from storage or it's compute, or you need an entire cloud in a rack, or something custom built that you've dreamed up for your crazy business, IX Systems will build it beyond your expectations. From sales to post-support, they blow all of your expectations away. ixsystems.com/TechSNAP. You go there to support the show, let them know you heard about it here, and maybe learn a bit more about the company. Go check out why Groupon and Splunk and Tumblr and Hitachi and the United States Air Force and many, many, many other companies are IX Systems customers. And while you're over at ixsystems.com/TechSNAP, swing by the blog. They have an OpenZFS Developer Summit report from October. And a friend of the show, Mr. Dexter, Michael Dexter, went to the OpenZFS Summit, and I believe this is his blog post here. He's often Michael Dexter, senior analyst at IX Systems, posted this. And it's good. It's got pictures in there. You want to know what they do at a file system summit? How do these new features get figured out? How do they work out porting details? And what did Alan Jude talk about? All of that's on the IX Systems blog. ixsystems.com/TechSNAP. Go there to learn more about a company that can build real solutions for your small business or your enterprise. ixsystems.com/TechSNAP. The robot is back. The return of the Bleichenbacher's Oracle threat. What's the robot attack, Wes?
Well, it's a 19-year-old vulnerability. Yeah, that's right.
Oh,
19-year-old vulnerability that has been rediscovered in the RSA implementation from at least 8 different vendors, including F5, Citrix, and Cisco. So these aren't no-name vendors.
Oh, boy.
That can give man-in-the-middle attackers access to encrypted messengers. So it's dubbed Robot, and it has like the best domain name ever, robotattack.org. If you want more information right from the researchers, that stands for Return of Bleichenbacher's Oracle Attack. And the attack allows an attacker to perform RSA decryption and cryptographic operations using the private key configured on vulnerable TLS servers.
So this was first discovered in 1998. And the Bleichenbacher name comes from the Swiss cryptographer Daniel Bleichenbacher, so hence the Bleichenbacher attack, which is a padding oracle attack. What is that? What's a padding oracle attack?
Well, padding is part of the process of encryption, and in this particular case, they're using RSA-based PKCS #1, version 1.5, and an oracle attack basically, the researchers are able to send encrypted text, and by the error messages sent in the encryption and decryption routines, they're able to determine if that is a properly padded ciphertext or not.
I see. So it's not Oracle as in the database company.
No, it's Oracle as in like yes or no, and so this is like they're able to pick up additional information without having to have the private key. They're able to ask like, is this ciphertext legit? And then get a yes or no answer. And by using those answers, they're able to piece together and decrypt the session after it's established.
I see. So they can ask a series of yes/no questions.
Yes, exactly.
Oh, man, that's
it's clever. It's exceedingly clever. Part of the problem here is that as we're talking about, this was discovered in 1998. We knew there were problems. What ended up happening is instead of replacing this algorithm entirely, there were some countermeasures put in. But these countermeasures are complicated and hard to get right. In these implementations, there are flaws, and so this vulnerability still exists.
Knock me over with a feather, Wes.
So back in 1998, Bleichenbacher proposed to upgrade the encryption scheme, but instead, the TLS designers kept the vulnerable encryption modes and added a series of complicated countermeasures to protect the leakage of error details. But now, a team of security researchers has discovered that these countermeasures were incomplete, and just by using some slight variations, this attack can still be used against many HTTPS websites. So that's really where this attacks, right? So it's SSL v2. A lot of HTTPS websites will be using this, as well as some VPN installations and anything else that might be encrypted over SSL.
Yeah, when you first suggested this story, I did a little reading, and I know that the researchers said that Facebook and PayPal were affected by the vulnerability.
Those are some big companies that have a lot of should be secure.
They just made a vague statement. They said the researchers found vulnerable subdomains on 27 of the top 100 domains ranked by the A word.
Yikes.
The A word we no longer can say because it sets off people's lady tubes.
So you might be wondering, how bad is it? For hosts that are vulnerable and only support RSA encryption key exchanges, it's pretty bad. It means an attacker can passively record traffic and then later decrypt it. For hosts that usually use forward secrecy but still support a vulnerable RSA encryption key exchange, the risk depends on how fast an attacker is able to perform the attack. The researchers believe that a server impersonation or man-in-the-middle attack is possible, but is more challenging. So yeah, a couple, big name vendors. You talked about a couple of the websites, F5, Citrix, Cisco. Worryingly, Cisco has at least one device that is out of support, but is vulnerable. So I don't know if we'll see updates for that.
That would be very kind of them. It'd be a holiday gift.
And you might be wondering, if you are affected, what should you do? Well, if you have the option, it's pretty simple. Disable RSA encryption.
Yeah.
Robot only affects TLS cipher modes that use RSA encryption. Most modern TLS connections use an elliptic curved Diffie-Hellman key exchange instead of RSA. So just disable it.
And the researchers have also released a Python tool to scan your host. So we will link to that in the show notes so you can check your HTTPS server to see if it is vulnerable to the robot attack.
How handy.
As we quickly approach the end of the year, there's lots of different retrospectives to pick from, but one seemed like particularly the right one to talk about on this show, and it's WannaCry. Now, you remember last November marked the 6th anniversary of WannaCry, which was one of the largest attacks that this show's ever talked about. But there's a couple of interesting elements. As you recall, this is supposedly based on leaked NSA exploit code, which is an interesting twist to the story. But there's another element to the story that I don't think is really widely known, Wes, and the folks that originally took this down with their sinkhole, they're still keeping it down. They're to this day still running an active kill switch at that domain that is stopping all of the attacks. And at the time that they did this retrospective, they've counted approximately 900 million cumulative thwarted attacks by having that kill switch still active.
Wow.
They say in the last 6 months since the attack, the count of installations of WannaCry has gone up. It's continued to propagate, and it's maintaining increasing foothold month after month, they say. It's still out there. It's still spreading. It's just that the kill switch is still active.
It really, it really speaks to the narrative. We think about like, oh yeah, the kill switch happened, and then the patches were issued, and okay, the problem goes away. But not really.
It really does show you that people aren't patching their shit. Right
exactly.
Here.
Yes, right here.
That's the moral. In June, the NSA released a statement of moderate confidence, saying they believe that North Korea was responsible for WannaCry. Kind of the big update is this last week, the U.S. government upped their possible rating to we officially think it was North Korea that started WannaCry. Also, the UK intelligence agency said that they think we strongly believe it came from a foreign state. And then during an interview for BBC4 Radio, Ben Wallace, who's a junior minister for security, told them that they were as sure as possible that that nation state was North Korea. So it's sort of been building to this for weeks, but this week it was boom, U.S. government's formally announced North Korea was behind WannaCry. They say this attribution comes from a number of contributing factors: code nuances, correlation to previous attacks, techniques and procedures, signals intelligence, which is just sort of a big black box. You're never going to get to know that one. And even potentially crash log information, they say, where they saw North Korean language symbols in there. And interestingly enough, Microsoft played a significant role in contributing to the U.S. government's assessment of WannaCry being attributed to North Korea.
Oh, interesting. I mean, it would make sense that they'd be interested, as it was a vulnerability in their SMB protocol.
TechSNAP.systems/349 will have a link to the blog post that goes into way more detail, lots of graphs and charts. But I'm left with one thought, and I want to hear what the audience thinks about this. What happens if this kill switch ever gets turned off? This company goes out of business, the kill switch somehow gets taken down. What happens next? TechSNAP.systems/contact. Let me know what you think. TechSNAP.ting.com. That's the URL to go to support this show and take $25 off a Ting device, or if you have one already, CDMA or GSM. Just check their BYOD page. You can get $25 in service credit. And that rocks, because Ting's a better way to do mobile. $6 a month for the phone, and then your minutes, your messages, and your megabytes. That's what you pay for. Whatever Uncle Sam takes in your neck of the woods, you got to account for that. But all said and done, your average Ting bill for one phone on a plan is going to be about $23, $25, maybe $30 if you're maybe not being too Wi-Fi savvy. It's great. I actually have 3 phones, and it's usually under $40. You pay for what you use. Nationwide coverage, no contracts, no early termination fee, a dashboard that lets you do everything from activate a completely new device, deactivate a device, set thresholds and alerts, everything you might want to do, never even having to pick up a phone. You can do it with Ting's website. But the crazy thing is, if you do call Ting, they're going to blow you away with their customer service. They're going to blow you away. And they take firm stands on things that our audience cares about. A lot of people talking about net neutrality these days. I encourage you, if this is something that matters to you, to go check out their blog. They've made a commitment to Ting customers about how they'll manage data, and I think you're going to like it. TechSNAP.ting.com. Linux network namespaces, something that's new to me, but something you have been messing around with for a little bit now. So let's do a Teach Chris. What is a Linux network namespace?
Great question, Chris.
Thank you.
So you've done some playing around with Docker and other container type services, right?
Oh, yeah.
So you have already used them. Network namespaces are a pretty crucial part of the hodgepodge of kernel features that have been come to be known Linux containers.
Is a network namespace similar to a process namespace?
Yes, it is. So the 2 building blocks of containers, really, I mean, there's more than 2, but the 2 main ones on Linux are C groups, which are control groups that lets you modify what containers or groups of processes, how much they can access. One example is the memory C group. And the other side of that is namespaces. And namespaces control what processes can see. So to read right from the man page, a namespace wraps a global system resource in an abstraction that makes it appear to the processes within the namespace that they have their own isolated instance of the global resource. I found one good example of this as a way to think about that. Over here on Stephen Brennan's blog, he was working on his thesis and dealing with network devices, think Ethernet and Wi-Fi cards. Though they could also be, virtual things, a VPN interface, whatever.
Oh, a VPN interface.
So back in the good old days of the kernel, you could iterate over the list of network devices quite easily, right? You would have to acquire a lock, sure, but then you just access this global linked list of all the interfaces. That made it easy. You could scan through, find whatever interface that you needed. But now we have network namespaces. That changes things, right? So network namespaces serve the same purpose as any other type of namespace. They help partition resources into groups so that processes can be placed in these namespaces and only have access to some of the available resources. These are the foundation of technologies like containers. In the case of network namespaces, the resources being partitioned are network devices along with firewall rules and all the other parts of the network stack. Unfortunately for him, this complicates things if you're looking to simply iterate over the available network devices, or even to just find one device. But I think that's a good way to think about it, because it really is taking things that used to be global for the whole kernel, like interfaces, and creating a structure where it's partitioned into namespaces, and each namespace has its own version of what was once a global list.
While it seems complicated, I could see how it could be almost infinitely useful too.
Right, exactly. And so now, instead of where you once had one global thing, when the kernel boots up and starts init, it gets its own namespace, right? And that's the init namespace that you start in, and then you can create new ones when you spawn new processes.
So what does that look like from the sysadmin standpoint? When I look at all my interfaces, do I just see 20 or 30 now, depending on how many I've set up? Are some invisible to user space? How does that work?
Okay, sure. So the way that you would really interact with this, and it's not new. Network namespaces entered the kernel in 2.6.24.
Yeah.
So even back in the 1204 days, you would have had access to this.
But they've gotten a little fancier recently.
Yes, definitely. So from the code perspective, when you create a new process, when you call the clone system call, you pass clone new net. But you're not going to do that on the command line, right? So for the command line, if you haven't already started using the new IP route 2 package, like the IP tool, rather than old busted if config, at least in the Linux world.
Yeah, I miss it.
Now and it works fine, right? You can still totally use it. It's not a problem, but it doesn't have some of these newer features like namespace support.
That is really the problem, is it's just sort of out of date. So I guess that was what I was thinking of when I said from the user's perspective and I wanted to enumerate my interfaces. I was thinking of like the good old classic if config.
Yeah, right, exactly. So to get started with this, you do IP netns for network namespace. Then you can do things like add, right? So if I do like add Chris's network, let's say, that creates a new network namespace called Chris's network. Now, when you run things like Docker, you can have like this unnamed namespace, right? It's basically just identified by whatever the PID of whatever process is running inside it. But that's not convenient for command line usage. So they have this facility basically by convention under var run netns. They just do some bind mounts under there, and that just keeps your namespace running even if there's no processes inside it.
So you can still see it right there on the file system. And it seems like the command syntax is really simple.
Yeah, it's not terribly complicated. So you can just IP netns add. That creates a new one. You can do list, IP netns list, if you just want to see all of them. Now, right there, you haven't really done anything, right? I mean, you've created this thing, but you haven't put anything in it.
Right, true.
There's a couple of things you can do. For starters, in this new world, each interface can belong in one and only one namespace. So you can move interfaces between them using the IP, same tool, IP link set netns, and then you like give it the name. So you can say like, oh yeah, take my Ethernet card, put it in this namespace. Or one example of that is I have a router at home that I'm doing this with. So it's a dual NIC Intel NIC. One of those gets put in a namespace. One of them does not.
Awesome.
Yeah.
That's really cool. And so they can't be in two namespaces at the same time.
Right.
So it's one namespace per interface.
Exactly. Now you think, okay, well, that's all well and good, but when you do that, so let's say you're on your machine, you have one ETH0 interface, and you put that in your new namespace. You're still in the init namespace, right? Because you haven't done anything, but you won't see that interface. Just boop.
Okay.
It's gone.
That's what I was wondering.
Yes. And so that's the power of namespaces. They manipulate what you see. So in your namespace, that interface just doesn't exist. If config won't see it, IP adder won't see it.
And then could I assign it to, say, a container? Or can I assign it to a process even? Like what can I do with that, say, once I have this namespace, but it's nothing's really using it?
Sure. So one of the nice things, you can do a lot of these features in other ways, but one of the really nice things about it is it has this container aspect. So where before maybe you could take a process, you could use some IP tables to like tag packets that are sent by that process and then apply a routing policy.
That would be
That does work, but it's very persnickety. You have to know exactly the right stuff. You have to know maybe where it's trying to send input or. Yeah,
and I just know that's not how you're supposed to do it anymore.
Right. And now what you could do, using IP netns exec, it lets you execute commands in a namespace. It's really easy. Ooh. It's really easy from the command line. A common practice, if you're just getting started, you want to play with it, is just to execute bash. And so it'll give you a bash cell in your new namespace, and then you can start processes. So any processes that you started in that namespace, they're only going to see the interfaces in that namespace.
Interesting. So I could do that for like all kinds of things: backups, torrents, Usenet, connecting maybe to a VPN even.
Yeah, absolutely.
So that bash shell would be the singular process on my system that's using the VPN, where everything else would be going up my main connection, but everything in this bash shell, whatever I launch from there, would be going out a VPN. Could I accomplish that?
Yes, you can definitely accomplish that.
Oh, I like this.
One way to do that is set up your VPN connection in the main namespace, and then you take your like ton interface and move that to your VPN interface, and then start your VPN process, whatever thing you want to use that VPN inside that namespace. Now that may not be the best configuration. What opens up a lot more options is when you learn about virtual Ethernet devices. They come in pairs, so virtual Ethernet pairs. Some people call them VETH pairs as well. And this lets you connect different namespaces together or containers, however you're using them. So you can think of them as a virtual pipe.
Yeah.
So you make one, and it comes with a pair, and anything that goes in one pops right out of the other. You just put a packet in, pops right out.
That's great. Okay.
And
it's like a virtual crossover cable almost.
That's exactly how you should think of it. And then what you do is you take one, you leave it in whichever namespace you want, and then you put its pair in a different namespace. Then you can assign IP addresses and ping between them and join those together.
Cool.
So in that way, you really are simulating the whole network stack. And so before, where maybe you wanted to spin up a whole bunch of VMs to do some simulation or testing, now you can just make network namespaces. Sure, you could make containers too, but there may be maybe you don't need any of those. You don't need the rest of those different namespaces and C groups for what you're doing. You just need different network.
There has been situations where I would like my browser to be in a different country, but I don't need Telegram or my other browser to be in a different country. This could be a way to accomplish that.
Yeah, exactly. And so it really gives you all these different levels of control. And because each namespace has its own version of IP tables rules, you can firewall in between namespaces in multiple configurations however you want, right? You can just kind of arbitrarily plug and play these together, and you can simulate a whole network.
So do you have any practical examples, or anything that would be like a takeaway and you could set it up yourself?
Yeah, there's a few things that, some things that are linked to. One is maybe you just want to run a process and not have any network access. You don't trust it. You need to use it, but you're a little worried. Maybe it's a proprietary application.
Absolutely.
So by default, when you make a new namespace, all it has is the loopback. So it won't have any internet access. It can't escape that. That's a great use case right there. Another thing you can do is there's a lot of interesting applications for application developers. In particular, let's say you have a web request or other system, and basically I want this process to only respond to this request and do nothing else. You can fork your new process, pass it the file descriptor of whatever socket that you have, and then put it in a new namespace. And then it can send over that socket that it has, but it can't start any new connections.
Well, maybe here's another practical example. I see in the show notes you've linked this article to WireGuard's site, where they're talking about how they use namespaces with WireGuard, which I think is a topic we may be speaking more about in the future, WireGuard itself. But for right now, just the purposes of this, how are they using namespaces?
Yeah, so WireGuard is a new proposed VPN for the Linux kernel and other systems. One example of this is you can make a WireGuard interface. It shows up as a VPN style interface, and you can use namespaces. So you can say hey, I'm making a new container, make the WireGuard interface the only interface in that container, right? So boom, VPN container.
That is so cool.
Yeah. Another example is routing all your traffic, right? So maybe you have this WireGuard connection, you want to route everything over it. They talk a little bit about some of the classic solutions to these problems. And I think this is where there's some fundamentally new stuff about namespaces. And that's where you see from the container side of things, it changed the structures that you're working with in the kernel and how they're thought about. There's also just some convenience things where you could do it with IP tables rules or policy-based routing or other techniques, but sometimes it's just simpler with namespaces. So one example, the example they have here is you're trying to route all your traffic. So the first thing you might try is just deleting your current default route and saying, hey, add my new default route, everything goes over WireGuard. But if that probably works fine on a server, but if you're on a laptop or something, let's say you switch Wi-Fi networks, DHCP daemons like to overwrite those sorts of routers. You know what I mean? So that's not going to work very well, right? So it turns out we can route all internet traffic via our WireGuard using network namespaces rather than classic routing table tricks.
So you can use namespaces itself to send the traffic into WireGuard. Am I following you? Or
Well, the way this works is that we move interfaces that connect to the internet, like ETH0 or WLAN 0, to a new namespace, which we're going to call the physical namespace. Then we have a WireGuard interface that's the sole interface in our Init namespace, which is the namespace associated with the init process and the default namespace for the system. So once you've done that, you can start up WireGuard in your physical namespace, right? It has access to the internet, and then you move that WireGuard interface back into your Init namespace. Therefore, any process you run in your main namespace, so your web browsers, anything else, the only interface they're going to see is WireGuard. Because the WireGuard process is started in your physical namespace, which has access to your ETH0 interface, it can send to the internet, right? And then you've moved the interface it's create, which let's call WG0, into this other interface, or this other namespace where you're running the rest of your system's processes. So all they see is the WireGuard interface. That sends it to the WireGuard process, which it can see ETH0. And therefore, but you don't have to you don't have to muck around with any default routes or anything like that.
Right.
Because it just works.
That's pretty neat. To be honest with you, this gets me even more excited about WireGuard, which I want to talk about more in the future. But I know there's a little more when it comes to like routing, asymmetric routing at that, Wes.
Well, just another example of something namespaces can be used for. Let's say you're on a machine that has two interfaces to the world. One is like is the main one, production traffic goes out there. And then you have a separate management interface that maybe you're connecting to out of band.
Sure.
A pretty common use case. You may get in a situation where we have some sort of asymmetric routing where you've come in the management interface, but then the default route goes out the other interface, right? So, and that will work, but maybe a stateful firewall in the middle isn't happy about it. It can cause some problems. Again, this is a situation where you could do some like fancy IP tables magic or other policy-based things to say like, well, if you come in this interface, come out this other one. By just making a management namespace and sticking the management interface there, you get access to the host. You can do everything you need to as root.
Sure.
But it just works.
Yeah, you're just inside that namespace.
One thing I did discover while looking into this, though, that works really well, especially if you just have a couple namespaces. More and more, though, we've seen Linux being used on networking gear, right? Like white box networking gear, switch-based operating systems. Turns out that emulating the entire network stack like this in this partitioned way with namespaces doesn't really scale when you want to have thousands of them.
Turns out.
At switch level speed. So Linux actually now has a more traditional VRF system, which stands for virtual forwarding and routing. Virtual routing and forwarding, rather. Let me get that right. And so what this is like, think VLANs to layer 2. This is the layer 3 equivalent. So it's another way to have per process routing tables, but without the entire overhead of a full namespace. So namespaces partition at the device level, VLANs partition at layer 2,
okay,
and then a VRF partitions at layer 3.
Right.
So that was neat. I didn't know about it. FreeBSD has some similar functionality. Turns out this was all added by Cumulus Linux as an open source contribution. They wanted something that would be performant on their switch gear, and now it's in the kernel.
Yeah, we have a link to their post as well. That's really nice. That's a great rundown. Thank you very much, Wes. And the WireGuard article that you found for the show notes is fantastically well done if you want to do another deep dive. And if you want to know more about VRF, just go to techsnap.systems/contact and let us know that you'd like to hear more about that, because that actually sounds pretty interesting too, and maybe more on the level of what I'm looking for as well. Thanks for the deep dive, Wes.
You know it.
DigitalOcean.com. Go to DigitalOcean.com, create your account, and use our promo code SNAPOcean. It'll give you a $10 credit at DigitalOcean, then you can spin up some infrastructure in less than 55 seconds. They've got servers all over the world, a very straightforward but powerful dashboard, and a simple API that's intuitive to use, and a bunch of great command line utilities are already built. It's easy to scale DigitalOcean into a large production environment or really just automate simple things. They have all kinds of storage options and team accounts as well. And take a look at the pricing. It's an unbelievable value. My favorite system is 3 cents an hour. It gets you 2 gigs of RAM, a 2-core CPU, 40 gigabyte SSD, because again, everything at DigitalOcean is SSD, and 3 terabytes of transfer. You can develop locally and deploy globally in San Francisco, Toronto, New York City, London, Germany, Amsterdam, Singapore, all over the place. India, they're spinning them up more and more all the time. That's why companies like Xerox, Atlassian, Docker, Zendesk, Red Hat, Akamai, and so many others use DigitalOcean. They're also a huge part of the open source community. DigitalOcean.com. Go over there, create your account, and then use our promo code SNAPOcean. That gets you the $10 credit. You can try out the $5 rig, 2 months for free, and then be sure to explore their community documentation section. Unbelievable, unbeatable, so well done. DigitalOcean.com. Use our promo code SNAPOcean. Thank you to everybody who went to techsnap.systems/contact or tweeted us to give us feedback on the show. Really, a lot of great feedback. Most of the people that are upset are on YouTube because you no longer get to see our faces.
We're sorry.
You are a handsome devil, Wes, so I can understand why they're upset. Although video isn't totally off the table forever. We'll talk about that more in the future. But right now I wanted to follow up on probably the most positive bit of feedback we got that maybe not everyone knows about. And people really seem to love the MP3 chapter support we put in the show. And if you don't have a podcast player that supports chapters, you might want to check it out. And if you do, take a look at the TechSNAP program. It's pretty neat because what we've done is we've time-coded out every topic in the show. And you can jump right to it. So you can just listen to that topic or you can find content really easily. And if your player supports it, the timecode will also have a hyperlink for the story. And a lot of times I can switch out the album art as well to give you a visual. So, for example, when Wes was talking about WireGuard namespaces, if everything works as I plan, there will be a WireGuard namespaces image on the album art.
Oh, that's beautiful.
And it rotates and then it goes back to our standard album art when there's no longer anything to show. And it's a quick way so that people can get a little visual guide, even though this isn't
a more immersive experience.
So my favorite podcast player in the entire world is Overcast, and I think it has the best chapter support because it even tells you, like, subchapter how long you have. Pocket Cast has a pretty good implementation. AntennaPod, Podcast Addict, as well as a bunch of others, have MP3 chapter support. And it's pretty neat. It's a great way to discover content in a long audio file.
I'm excited for reviewing past episodes of this show later.
Yeah.
Jumping right to what I want to listen to.
Yeah, that could be really nice, especially when you're going through the back catalog for like a best of series or something like that. We didn't get a lot of questions into the show this week because a lot of people were just following up on the format and giving us their thoughts. Thank you, everybody, for doing that. But we did get one follow-up item I want to touch on and one question. The follow-up comes in from Pierre, and he says, you asked, why would somebody need a keylogger for developing an audio driver? Remember that story when we talked about HP last week? He says, the only reason I could think of is that you'd want your driver suite to react to keystroke like function keys. You know, maybe like the volume ups or something. And in times where virtual on-screen keyboards are more and more a thing, I can imagine that if a system ran with different locales and different key codes, you might get from it, especially on virtual keyboards, then it would just be easier to track all of them by logging them somewhere later on, and then teach your software to react to the ones you've logged. That's the best I could come up with. Cheers, Pierre.
I mean, I think he's onto something there, that it is probably just lazy debugging, and well, it was super easy to flip this big knob over here, so I did.
It's funny though. It's like, oh yeah, we had a keylogger in the touchpad driver. Oh yeah, we had a keylogger in the audio driver. It must be useful because they're sticking them everywhere.
Doesn't that just sound like a Windows driver, though? Oh yeah, I'm your audio driver, but let me just hook into everything.
Yeah. Youssef writes in with a question he's having with the Linux cluster. He says, "Hello, TechSNAP. I run a big cluster in Alexandria, Egypt.
Neat.
For certain faulty nodes on the cluster, the DHCP server keeps logging DHCP discover and then DHCP decline over and over again, which ends up flooding syslog. I know that there are faulty machines that I need to just deal with. However, it would be really convenient if the DHCP server could just automatically ignore excessive DHCP discover packets from such clients. I was thinking it may be possible to do such rate limiting via something like fail to ban or something similar. Any suggestions are much appreciated, and welcome back to the show, Chris. Youssef." Well, thank you, Youssef. What do you think, Wes? What could he start with here? Besides obviously just fixing the damn machines.
Right. I mean, I think that is probably one place one could start. It depends on how many of them there are, what access to logging you have. I would be curious to know what DHCP server is running here. That might be helpful too. One thing I can think of, I don't know if fail to ban does support DHCP requests or not. We'll have to look into that.
I'm doubtful.
But I have seen, I've never done it, but I have seen people who used EB tables, which is basically the Ethernet equivalent of IP tables on Linux. You can then tag packets, so you could tag packets that came from the MAC address of some of these faulty clients, and then use TC, which is the traffic control program, to rate limit requests from those machines. I don't know if it would work. I don't know how easy or reasonably workload that would be, but one idea.
Youssef, my read here is that you might need a little more data to be able to make a better decision. So see if one of your switches supports DHCP snooping. I know Cisco Catalyst switches can do that. There may also be some command line tools. Of course, TCP dump could be another way just to get some insights into the traffic to maybe give you a better idea of what you would have to rate limit, what you'd have to block, or hopefully what the root cause is, because obviously that would be the better solution overall. But check out DHCP snooping and check out TCP dump to get more information. And if you discover anything further, please do follow up, because I'd be really curious to know what ends up happening. Just go to techsnap.systems/contact. And if you have a question for the show, that is the best place to submit it. You can also tweet us. I'm at ChrisLAS, and he is at Wes Payne. If you want to just give us a quick and short question, I'll try to tag them throughout the week and drop them in there.
Well, Chris, one thing you should know about me, I'm not a huge fan of WordPress. Yes, they've made some strides in recent years to do a lot better with updating. One big problem they still have, though, is sketchy plugins, and once again, it's in the news.
Yeah, this is the kind of stuff that does give me heartburn, because you're going along using something completely legitimate. It gets sold out. You don't even know. The company just sells out, and then it gets sold to a malware author who then uses the auto-update mechanism to deploy a backdoor to your WordPress installation. Yeah, this affected over 300,000 WordPress sites. A popular plugin with a large user base was essentially sold. It was a CAPTCHA plugin. So if you want to add a CAPTCHA to your WordPress site, you just install this thing. You got a legitimate CAPTCHA until it was no longer legitimate. The undisclosed buyer modified the plugin to download and install the hidden backdoor. WordFence security firm revealed that they discovered this and that it was on 300 active installations. Oh, man. And they labeled it as a severe backdoor, Wes, that could allow the plugin author or attackers to remotely gain administrative access to WordPress websites without requiring any authentication. Just get right in there. Just let me see what we have here. The backdoor code was designed to create a login session for the attacker. The plugin author then, in this case, would get administrative access, allowing them to gain access to any of these 300,000 websites. And the code was pulled down from the original remote server that the plugin came from, and it was signed because the guy had authorized access to all of this. It was a legitimate plugin and a legitimate repository, so it passed all of the automatic updates and just went out to everybody. The article goes on to say, but I think we all know this is just going to become more and more common, because the trick here is just have a little cash set aside from some of your other illegal exploits, and then buy out one of these mid-level plugins and get access to a few more sites, sell that, and just keep on rolling. It's like WordPress flipping. Yeah,
one of the problems here, I think, is just the fundamental nature, right? WordPress makes it super simple, and most users, especially, intermediate users, really rely on the power of these plugins. There's a lot of this implicit trust where, oh yeah, this plugin will do this, and then it lets me do this stuff I couldn't otherwise do. That's where it can really break down, because you don't have a lot of tools to audit. You're not ever looking at the source of these things. How are you going to know?
Everything's signed, Wes. Why should I worry about it? The lesson there is always be checking your WordPress installation. Yeah. That's the price you pay. I'm a WordPress user. It is a great tool. I've gotten a lot of value out of it, but this is the price I pay. Is I have to stay diligent, and I don't always.
Yeah.
I feel like, oh boy, maybe I shouldn't be using WordPress.
I would definitely recommend static websites. If you can at all do that, there are some workflows where you can get semi-dynamic content in there, and there's just a lot safer. If you do have to run WordPress, make sure you deploy it from source control, and that all of the places you have actual state, so the files on your file system and the stuff in your database is regularly backed up.
That's a great tip. That is a great tip, and that would solve so many problems when something like this rolls around, because you could just go back to a known good state. That's a great way to run. Maybe I'll do that one day. That, or I'll just switch everything over to static sites. And I think that might be the direction.
That's the way to go.
Thank you very much for joining us on this week's episode of TechSNAP. Thank you to our three wonderful sponsors, DigitalOcean, IX Systems, and of course, the wonderful folks over at Ting. Please consider visiting all of our sponsors if you've enjoyed the new show, because it's because of them we are here and continuing, and it's because you visit them from time to time and even patron them from time to time that it keeps us going. We appreciate that very much. I'm at ChrisLAS on Twitter. He is at Wes Payne. The network is at Jupiter Signal. And if all goes as planned, we'll have one more episode next week. We'll be off for a week, and then we'll be back. Can you keep track of all that? I think we got it.
So.
Thanks for joining us.